Today we're going to talk about the volume of a cone. Before we get into the volume of a cone, I think it's important that we talk about the different parts of a cone. So starting on page 16 in your packet. Okay. Here is the official definition of a cone. A cone is a three-dimensional object with a circular or oval base and one vertex. So this is an example of a cone. So I have a circular base and then one vertex. Where you would see a cone in the real world, like an ice cream cone or a traffic cone, or like a snow cone at some places are in this form. This is a cone. So if we go down to question 3, how does the radius of a cone compare to the radius of a cylinder? Well, if we think about it, we have a cylinder that looks like this. It has 2 circular bases. And we have a cone that only has 1 circular base, but the radius is still going to be halfway across the circular base. So the radius halfway across the circle. The radius is always halfway across the circle. The height of the cone is the length of the line segment drawn from the vertex to the base of the cone. So, for example, look at cone A. Let's identify the radius. The radius is halfway across my circular base. The diameter of my circle is all the way across that circular base. And the height of the cone is the distance from the point all the way to that base. This is my height. It doesn't matter if the cone is laying down or standing up. So like for example, this one, the height of my cone is the distance all the way from the base to the point of my cone. That is my height. And my radius is going to be halfway across that circle. And my diameter is going to be all the way across. So if in a problem they give you the diameter, we just know that we need to divide it by 2 to figure out what our radius is. On page 17, they talk about the relationship between a cone and a cylinder. So I know that question A is talking about the nets. So if I were to open up a cylinder, I would have a circle and a rectangle and then my other circular base here. If I were to open up the cone, it would look like this. So what is the relationship between a cone and a cylinder? The volume of a cone and a cylinder? So a cone's volume is 1/3 the volume of a cylinder with the same radius and height. A cone's volume is 1/3 the volume of a cylinder with the same radius and height. I will also provide a video that shows the relationship between the volume of a cone and a cylinder. So you can actually see that the cone is 1/3 the volume of the cylinder. Going to page 19. Here's again where they talk about how if a cylinder and a cone have the same radius and the same height, that the volume of the cone is a third of the volume of that cylinder. So now let's get into volume of cones. If we look at our star chart, and let's go to the volume section. Today we're looking at cones, and the formula for the volume of a cone is V equals 1/3 big BH. So the reason why there's a 1/3 in front of this big BH is because a cone is a third the volume of a cylinder, which we learned about earlier. So V equals 1/3 big BH. Remember, big B means area of the base. And what shape is my base of a cone? Well, this shape is a circle. So I get to plug in the formula for the area of a circle, which is pi r squared, for big B. Here's an example. Here is my cone. I know I'm looking for the volume, so the formula is V equals 1/3 big BH. I know that big B stands for area of the base, and my base is a circle, so I can use the circle formula, so area of a circle formula, which is pi r squared. But I still need to multiply 1/3 in front, and I still need to multiply it by the height of the cone. So all I did was instead of having big B, I plugged in the formula that I would use for big B because my base is a circle. So now when I'm looking at my shape, I need to identify two variables so that I can substitute it into my formula. I need to know my R, my radius, and my H, my height. So looking at my cone here, I see that my diameter all the way across my circle is 22. So my radius is going to be 22 cut in half. So 22 divided by 2 is 11. So my radius is 11 centimeters. My height is the distance from the point of the cone all the way to the base. And so they labeled that for me as 10 centimeters. So now that I know my R and my H, I can plug it into the formula. So I have 1/3 pi. My R is 11, so I have 11 squared. And then I'm going to multiply that by the height of my cone, which is 10. I can go into my calculator. And I can type this in exactly how it looks. So I have 1/3 times pi, 11 squared, times 10. Enter. So the volume of this cone right here is 1,267 and 11/100ths. Its volume, so I'm doing centimeters cubed. So when finding the volume of a cone, it's important to know, number one, your formula, V equals 1/3 big BH, but also to know big B means area of the base, and I can plug in the formula for the area of a circle for big B. You will complete the practice problems on your Google form, submit the Google form, and then you may continue the practice problems in your packet on page 20, 21, and 22.